Good morning to all. Myself Brinda from ECE department and King's College of Engineering. In this session, we are going to discuss the types of edge triggering. So before topic, we are generally discussed what is sequential circuit, what is latches, what is flip-flops, like that. In combinational circuit, what we discussed, the output is fully depends on the present state. But in the sequential circuit, the output is not only depends on the present state, but also consider the previous state. This is the basic block diagram of sequential circuit. Every digital system is like having a combinational circuit. Most systems encoding in the practice also including storage elements, which requires that the system be described in terms of sequential logic. Okay. In the memory element, are connected to the combinational circuit as a feedback path. So the connection between the memory element and combinational circuit is called as a feedback path. The information stored in the memory element is any time define the present state of the sequential circuit. Okay. So next one is synchronous clocked sequential circuit. So synchronous clocked sequential circuit means the sequential circuit may use flip-flops to store as many bits as necessary. Output can come either from the combinational circuit or from the flip-flop path. That means the flip-flop means it can store only one bit at a time. If you want to store many bits at a time means we require the memory element. So here flip-flop is act as a memory element. So the output it may be from the combinational circuit or from the flip-flop. But in the sequential circuit is fully depends on the clock pulse signals. Okay. Next one is what is flip-flop, what is latches, like that. So the state of the latches or flip-flop is switched by the changing in the control input. The momentary changes is called as a trigger. The momentary changes is called as a trigger, and the transition is cause is set to trigger the flip-flop. The D flip-flop, which pulses its control input, is essential a flip-flop that is triggered every time the pulse goes to the logical 1 level. Okay, that means the flip-flop is that device that normally samples its input and changes its output only at a time determined by the clock signal. The latch is the sequential device that checks all of its inputs continuously and changes its output according at any time independent of the clock signal. So that is the definition of flip-flop and latches. Okay. This is clock response in the flip-flop. Clock response of the flip-flop. Okay. So the clock response of the flip-flop means that is triggering. Okay. The output responds to the changes in the output only at the positive or negative edge of the clock pulse at the clock input. If you are giving the clock input means what is the output is calculated means if your the clock pulse is following the forward position means that is the positive edge triggering. If the clock pulse arrow is following the reverse position means that is in negative edge triggering. So the edge triggering having two types. One is positive edge triggering, another one is negative edge triggering. In this diagram they are discussed. Positive edge triggering means the output responds to the changes in the input only at the positive edge of the clock pulse at the clock input. Okay, that is positive edge triggering. So what is negative edge triggering means the output responds to the changes in the input only at the negative edge of the clock pulse input. Okay, so this is negative edge triggering. So next one is edge triggered D flip-flop. Edge trigger D flip-flop. The first latch is called as a master and the second latch is called as a slave. Okay. The master can be constructed by the any type of flip-flop. The master slave or as flip-flop is given below. In this, the D flip-flop is given below. In this D flip-flop is given below. The master slave flip-flop is connected by two flip-flop. One flip-flop act as a master, another flip-flop act as a slave. It consider of master and slave flip-flop and as a inverter. Both of the flip-flop are positive level triggering, but the inverter connected to the clock input of the slave. So flip-flop force it triggered at the negative level. The output state of the master flip-flop is determined by D input at the positive clock pulse. Okay. The output state of the master is then the transferred as the output is the slave flip-flop. The slave flip-flop used this input as the negative clock pulse to determine its output state. Okay. Generally we know that what are the types of flip-flop that flip-flops are there: RS flip-flop, JK flip-flop, D flip-flop, T flip-flop, like that. D type positive edge trigger flip-flop. So this is the structure of D type positive edge trigger flip-flop. Another more efficient construction of edge trigger D flip-flop uses 3 SR latches. That is, S means set, R is reset. Okay, 2 latches responds to the external D data. D is data, and CLK means clock input. Okay, the 3 latches provide the output of the flip-flop. The 3 latches provide the output of the flip-flop. Okay. So this is a structure. Here we are connecting a D flip-flop like this way. CL is a clock. Okay. Next, graphical symbol of edge trigger D flip-flop. Graphical symbol of edge trigger D flip-flop. Okay. This is the symbol of D flip-flop. D is the input and C is a clock input, and the output is Q, and then the complement output is Q bar, like this way. So in this position, this is a clock edge. At the same time, the negative edge, in this negative edge, D is the input, but clock is the negative position, negative direction, downward direction. That's why it is denoted as a complement. Okay, the knot is represented as complement. Okay, the output is Q, and another output Q bar is Q bar. So next, the characteristics equations of D flip-flop is characteristic equation Qt plus 1. Q is the present state, Qt plus 1 is the next state. So T plus 1, Qt plus 1 is the next state. The next state means what is the characteristic equation for D flip-flop is equal to D. And the JK flip-flop characteristic equation is Qt plus 1 is equal to J Q dash plus K dash Q. This is the characteristic equation of JK flip-flop. And T flip-flop characterization equation is the next stage. Qt plus 1 is equal to T XOR Q. That means we know that what is the XOR expression means T Q bar plus Q bar T bar Q. That is the XOR expression. Okay. Okay, thank you. In this lecture video, we are discussed what is the sequential circuit, what is flip-flop, what is latches, what is the triggering, the types of triggering, the T flip-flop triggering process are we discussed. Okay, thank you.